All right, welcome back to another example with diagonalization. As I mentioned last video, we are going to do a long example, and here we are, long example. So let's get right into it for this one. So we have to show that the matrix A is diagonalizable, and then we have to find a matrix S such that S inverse, or I guess the way I like to say it, SAS, is a diagonal matrix. So there's many ways to check if A is diagonalizable. The first one is pretty much finding S and then multiplying it to get a diagonal matrix. The other one is one of the theorems in which if there is an n number of eigenvectors, then that means A is diagonalized. So let's get to it. So the first thing we're going to do is the characteristic equation. So we can find the eigenvalues and eigenvectors. So let's get started. 1 minus lambda. Then we have 1, negative 3, negative 1, 3 minus lambda, 1, negative 1, 1, then negative 1 minus lambda. Yeah, it's not nice. So we're gonna set this equal to 0. We're going to, well, this has to be equal to 0. We're gonna use the first row to do our determinant. So the first row, we're gonna get 1 minus lambda times 3 minus lambda times not 1, negative 1 minus lambda minus 1. So now we are going to do the second column, and that would be minus negative 1, so this would be plus 1, and then we'll have 1 times negative 1 minus lambda minus negative 3 times 1, it's negative 3, so it'll be plus 3, and then plus negative 1, so this will be minus 1. This is going to be the last one, so this would be 1 times 1, it's 1 minus negative 3 plus 3, 3 minus lambda, and this is all equal to 0. Cool. So now I'm gonna play around with this, get this and find the roots. I remember how to find the roots. Actually, no, it's not that hard. So we are going to simplify everything. I'm gonna try to see if we can factor out a linear, so we can have a linear and a what's that thing called, quadratic. But if not, then we're gonna have to do it the long way. We are going to do 1 minus lambda times negative 3 plus lambda squared, minus 4 lambda minus 1. Is that right? No, that's not right, because it's negative 1 times negative 1. That would be positive 1. So this would be minus 2 lambda. And this would be plus 2 minus lambda, then minus 3 times 3 is 9 plus 1, 10 minus 3 lambda. And that is equal to 0. So we're going to have 1 minus lambda times lambda squared minus 2 lambda minus 4 plus 2 minus lambda plus 3 lambda minus 10. This part here would just be equal to 2 lambda minus 8. And then here we cannot factor out anything. So the unfortunate part is we're gonna have to do this the long way. Okay, so the long way is put this on a cubic. So we're gonna simplify all this. So this part, that stays the same, lambda squared minus 2 lambda minus 4 minus lambda cubed, just multiplying these out, plus 2 lambda minus plus 4 lambda. Oh, plus 2 lambda squared. And then I'm going to bring this together. And so we are left with negative lambda cubed plus 3 lambda squared minus 2 plus 4 plus 2 plus 4 lambda minus 12. Set that equal to 0. So now we have to do this the long way. We're going to use long division. And to do that is we're simply going to use another color. Write down lambda cube plus 3 lambda squared plus 4 lambda minus 12. And we're going to divide it by a linear function, which we don't know. So we're going to start with lambda plus 1. And if that doesn't work, then we're going to do lambda plus 2. So there's going to be lambda squared. And then this will be lambda cube plus 2 lambda squared. So subtract that, we'll have lambda squared be plus lambda, and this will be lambda squared plus lambda, be 5 lambda, be plus 5, and this will give us negative 12, which is a remainder, which we don't want. So that means the plus 1 does not work. So that means we have to go up again and do, or up 1 and make it plus 2. So again, this will be lambda squared, and so we'll be left with lambda cube plus 2 lambda. Subtract them out. Oh, this is negative, my bad. It's supposed to be negative. So it'll be positive, those cancel out, and you'll have 5 lambda. So this would be plus 5, not lambda, plus 5. No, yeah, plus 5 lambda, because this is lambda squared. Okay, plus 5 lambda, and then this will give us those two cancel out. So we're left with negative 5 lambda squared plus 10, not plus, minus 10 lambda, and this will give us negative 6 lambda minus 12, and that will give us minus 6, and this will just go to 0. So we know lambda plus 2 is a factor, so I'm just gonna rewrite this as lambda plus 2 times negative lambda squared plus 5 lambda minus 6. We can factor out this part, so we are left with lambda plus 2 times negative lambda. This will be plus 2, then lambda plus 3, not plus, minus, because it has to be negative 6, minus 3. And so we'll see that our eigen values will be negative 2, 2, and 3. So now we have to find our eigenvector. Oh, I need to see the A. Okay, so when lambda is equal to negative 2, we get that this would be 3, 1, negative 3, negative 1, 5, 1, negative 1, 1, and then 1. Negative 1, yeah, 1. And so we have to figure out what eigenvectors would give us. I'm not going to put this in row-decisional form. We're going to use the guess and check method, and so that will be let's cancel out the second one. So the second one will be, this will be 1, this will be 1, and then this will be 1 times 1, 5, 4. No, this will be negative 1, this will be negative 4, because then that'll be negative 1 plus 5, negative 4, or that'll be 4, then minus 4. Okay, so first row, second row checks out. The first row will be negative 3 minus 1, negative 4. Then negative 1 times negative 4 is 4. Okay, row 1 also checks out. And then the last row, negative 1 and negative 3 is 3, plus 1, that's 4, negative 4. Okay, cool. Oh, let's go. First try. So this is the first one. The second one will be lambda is equal to 2. And this will be negative 1, 1, negative 3, negative 1, 3, not 3, 1, 1, negative 1, 1, negative 3. And so for this one, the eigenvector will be, we cancel out the third row. So that'll be, oh, we can make this negative 0, positive. Because then that'll be 3, 0, negative 3. And then right here will be negative 1, 0, 1. And then it should be 1, 0, negative 1. Alright, so that one was easier. Then this last one will be lambda is equal to 3. And so this will give us 1 minus 3, 1 minus 3, negative 2, 1, negative 3, 1, 0, 1, negative 1, 1, negative 4. And so our eigenvector will just simply be, we can't use the second one. Do the first row, looks easier. So the first row will be 1, that'll be negative 2, and then we can make it with 1, so that'll make it 1, negative 1, and then 1. So that will mean, it'll be negative 2 plus 1. Oh no, this will be negative 1. This will be negative 1. It'll be negative 2 plus 1, which will be negative 1, plus another 1 will be 0. And the second row will be 1, 0, minus 1, 0. And the third row will be negative 3 plus 1, and that'll be negative 2 plus 4, that'll be 2. Okay, so this one will not work. Okay, so this one will not work. Okay, so now let's try. Alright, then, okay, let's switch to the third row. I have negative 3, so keep that as, no, make this inverse. And then 1, keep that as 1, so we'll have 3 plus 1 is 4. Change that to negative 1. No. Keep that as 1. So now we'll have, yeah, so it'll be 3 plus 1 minus 4, and then we'll have is negative 1 plus 1, and then we'll have 2 plus 1, 2 plus 1 minus 1. Okay, that one won't work either. Okay. So let's try, okay, let's keep 3. So this will be 1, be negative 3, and then minus 1. So it'll be negative 4. Then minus 1 will be 4, we'll make it 0. Then second row will remain the same. The other one will be negative 2 minus 1 plus 1. Hold up. Oh, I'm so dumb. Wow. This is the same thing as this one, but it's just multiplied by negative. I left out the negative 1. Wow. Okay. You know what? That makes, okay, so hold up. That means this one will be negative 2. No, it will be 2 minus 1 minus 1. So the first one checks out. Second one checks out. This will be 3, 1, 4. Okay, so this one's right. This one's the same thing. Okay, so we're gonna use this one. I left out the negative, my bad. Now we have everything to find our S. So our S will simply be negative 1, 1, negative 4, negative 1, 0, 1, and then negative 1, 1, 1. Now our S inverse, that will simply be negative 1, negative 1, negative 1, 1, 0, 1. -4, 1, 1, 1, 0, 0, 0, 1, 0. We add everything by 1, and then cancel all that out. Oh, add all that. Okay, so add all that. This would be 0, -1, 0, 1, 0, 1, and then -4, 1, 1. And so we added that together, so it'll be 1, 1, 0, 0, 1, 0, 0, 0, 1. Next, we have change that to a negative, and then we can subtract. Oh, add these. Actually, add this one, change it to a negative, and then add this one as well. Okay, so this will be 0, 1, 0, 1, 0, 1. Add that one together. Yeah, so it'll be -4, 0, 1. And so this will become a negative, -1, -1, 0. This will remain unchanged. And then this part will be added to that one. So it'll be 1, 1, 1. So now what we can do is subtract this one, flip that one. Okay. So we're going to flip 1 and 2. So that way this one remains the same. And then we're going to subtract 1 and 3. So this would be -5, 0, 1. No. And so we flip. So it'd be 0, 1, 0. Then -1, -1, 0. And then we subtracted this and this. So this would be 1, 0, 1. And then divide by 5. And flip it. So it'd be, or -5, so 1, 0, 0, 0, 1, 0, 1, 0, 1. This would be -1/5, 0, -1/5, -1, -1, 0, and then the 0, 1, 1, it would be 0, 1, 0. And then we subtract. So we have our inverse. Just gonna write I for inverse. And then here we'll have -1/5, 0, -1/5, -1, -1, 0. And then here we'll have 1/5. This would be 1, +1/5, +1/5. And that is our inverse. And so now we have to, we're almost done, to use the equation diagonal is equal to SAS. And so be the same thing as -1/5, 0, -1/5, -1, -1, 0, 1/5, 1, 1/5. Multiplied by A. I forgot what it was. So 1, 3, 3. So it'll be 1, 1, 3, 1, 3, 1. Then 1, 1, 1. So 1, 1, 1. Then this is negative, 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 negative. Then multiplied by S. -1, 1, 4, -1, 0, 1, then -1, 1, 1. So what we end up getting is the inverse remains unchanged for now. -1, -1, 0, 1/5, 1, 1/5. And so now we have -4, 0. Okay, that'd be -3. Second row will be 6. That'll be 0. Then -1 times 3 plus 1 should be 3. Then the last one will be, I really hope I'm doing this right, 0. Then we have 3. -1 is 2. and we have 3 plus 1 is 4 minus 1 is 3. And then now we have to add this together. I am not liking this. This does not look nice. I feel like I messed up somewhere. Yeah, this is not right. Okay, I can already tell this is wrong. Okay, so let me redo the multiplication. Okay, you have negative 1. 1 times negative 1 is negative 1. Oh, okay, I think I know. But yeah, negative 1 minus 1 minus 4. Oh, it's not minus. It's minus. Oh, I left out the okay, I see what I did wrong. This is wrong. Okay, redo this part. So this would be negative 1 minus 1 plus 4 is equal to 2. And then we'll have negative 1, negative 1, 0, negative 1. That'd be negative 2. No, not this one, the other one. Negative 2. And then this will be negative 1, 3, 2, and then negative 4, negative 2. And then here we'll have negative 1, 0, 1. That'll be 0. And then this will be negative. This will be 3 plus 1, 4 plus 4 is 8. And then negative. This will be 3, 0, 2. Okay, this one looks a lot better. So now I multiply these. So now we have negative. Okay, I'm still not liking this. Negative 2/5 plus 0. Wait, hold on. This would be negative 1/5 times 2, negative 2/5. 0, and then we have minus 8/5. So we'll have minus 2/5 minus 8. So minus 2 minus 8 equals negative 10 over 5 is negative 2. Okay, okay, so this actually might work. And then we'll have 2/5, 0, negative 2/5, that'll be 0. Then we'll have 3/5 minus 3/5 is 0. Second row we'll have negative 1 times 2, then plus 2, that'll be 0. Then we'll have negative 1 times 2 is 2, plus 0, plus 0. This would be 2, and this would be 3. Minus 3, that'll be 0, plus 0, 0. And then finally we'll have 1/5 times negative 3, no, 1/5 times 2, so that'll be 2/5 minus 2 minus 8/5, no, plus 8/5. So we have 6 over, no, we'll have 8 plus 2 is 10, so that'll be 2 minus 2 is 0. Then we have 1/5, so it'll be negative 1/5, 0 plus 1/5, that is 0. Then we have negative 3/5 plus 3 plus 3/5. Those 3/5 cancel out and we're left with 3, and there you go. This is our diagonal matrix, and you can see that the eigenvalues are present. Like I said, this was a very long example. Yeah, and this is the process on how you have to do it. You have to find a characteristic equation, find the roots, find the eigenvectors, find the inverse, and it's really simple. But what's gonna throw you off is the math, because you have to do a lot of math, especially like finding the roots of a cubic function. If it's higher dimension, it's like higher dimension function. And then the inverse, we have to do the whole super augmented matrix and then move the identity to the other side, and the multiplication. So there's a lot that can go wrong with the algebra, so be on the lookout for that. But other than that, it's the same thing. It's just much more tedious and longer. And this concludes this video. This took so long, I apologize, but hopefully this actually helped you out with you guys, and I'll see you guys in the next video.